Lesson 7.5, Compare Proportional Relationships. In this lesson, you'll learn to compare proportional relationships represented in different ways. First, take a look at the solve and discuss it. See if you can determine which orchard Mei Li should choose. Come back and check your answer. In this problem, you can use a comparison of the unit rates to determine which orchard has the best value for apples. Mei Li should choose Annie's apple orchard because after comparing the unit rates, Annie's apple orchard costs about 36 cents per pound of apples, while Franklin's fruit orchard costs about 42 cents per pound of apples. In this lesson, we're going to be using proportional relationships, like we did back in a previous topic, to compare different sorts of relationships. Now let's look at example 1. Compare proportional relationships represented by tables and graphs. Mira is researching cruising speeds of different planes. Which airplane has a greater cruising speed? You see Cessna 310 has information presented in a table. The jet airliner has information presented in a graph. We need to use the same sort of relationships, whether it's presented to us in a table or a graph, in order to make this comparison. First, see if you can find the cruising speed in kilometers per minute for the Cessna 310 and for the jet airliner. Looking at the data from the table in the Cessna 10 and going to step 1 in the solution process, you can see that the distance divided by time, or kilometers divided by minutes, is always 8. That is a proportional relationship. Remember that to find that constant of proportionality, or that unit rate, you are taking the y value, which is the distance, and dividing it by the time, which is your x value. So in each of these cases, kilometers per minute is your unit, and this plane has a cruising speed of 8 kilometers per minute. In step 2, you're going to do the same thing with the cruising speed of the Boeing 747. Recall from our previous work with proportionality that there are 2 ways to find this cruising speed for the Boeing 747. One way is to look back up at the graph and find the point 1, r, where 1 is the x value, or in this case the time, in seconds, and the y value is your rate. So when you do a comparison of the rate per 1 second in this case, then what you're doing is you're looking for that unit rate. You might also notice that at some point in time, although they don't show it to us here, they did take the units from the original graph and they have transferred them over so that they are talking common units, as with the Cessna. So in the original graph, the jet airliner was in meters per second, and they have made a new graph that is now comparing it in kilometers per minute. So they did some unit conversion there in order to make sure that they were comparing similar things. All right. So now what we do is we can look at this, but again, the problem is that in this case, the point 1, r, or 1 minute, and the unit rate in kilometers does not exactly line up anywhere here that we can tell on that y-axis. So it's going to be very difficult for us to make a determination what that unit rate is. So we have to go to plan B, which is the other way that we can find that unit rate, by using other points that are on the graph. Okay, and hopefully you remember some of this from our previous topic on proportionality. And the way that we do that is we find 2 other points on the graph. In this case, they found the point 4, 60, standing for 4 minutes and 60 kilometers, and 6, 90, which stands for 6 minutes and 90 kilometers. And then what they do is they look to see what the constant of proportionality is between those. Okay. You can do a 60 divided by 4, which is 15 kilometers per 1 minute. And compare that also with the 90 to 6 ratio, which is also 15 kilometers per 1 minute. Now you'll notice that on the graph itself, they have a 30 and a 2. And what they did is they found the difference between 60 and 90, which is 30. And then they found that's the y difference. And then they found the difference between the x numbers. The difference between the 6 and the 4 is 2. And you'll notice that that also helps us define that 15 kilometers in 1 minute. So in this case, we know that the Boeing 747 is going faster and has a greater cruising speed than the Cessna. Now try the try it problem here at the bottom of the page. One thing that I want to make sure that you remember is that when we talk about proportional relationships, that equation is y equals k times x, where k is that constant of proportionality. Come back and check your answer when you're ready. In this try it problem, using the equation for Josh, y equals kx and y equals 2 5/10 times x, means that Josh can make 2 5/10 birds in 1 minute. Remember that the 2 5/10 is the number of birds, that's your y number, because your k value is equal to y divided by x. Remember, y is your birds, x is your time. Okay, and then when I do the same thing for Marlowe, I need to choose a couple of points to make sure that I have the correct constant of proportionality. And you'll notice that Marlowe is only making about 2/10 of a bird per minute. So Marlowe's working much slower, which means Josh right here is the one working at the faster rate. Next, let's check out example 2. Compare proportional relationships represented by graphs and equations. The graph on the right represents the rate at which Daniel earns points in his video game. The rate at which Brianna earns points in her video game is represented by the equation y equals 2x, where y is the number of points and x is the time in minutes. At these rates, who will earn 100 points first? So the first thing that we need to do is find Brianna's rate. So looking at the equation y equals 2x, we're substituting 1 for the x because that's the time in minutes. That's your x value. You can see those easily on the graph. Okay, and where she has spent 1 minute, how many points does she get? Well, when you substitute 1 in place of the x and you solve, it says y equals 2, which means Brianna earns 2 points per minute. Now, going over to the graph, you're looking for that point for Daniel. And the point for Daniel is the one that is at the location 1, r. So where is that ordered pair on the graph? And it's this ordered pair right here. The point 1, 3 for Daniel represents his unit rate, which means he earns 3 points per minute. And therefore, Daniel's earning points at a faster rate. He will get to 100 points first. And finally, let's check out example 3. Compare proportional relationships presented by graphs and verbal descriptions. The graph represents the cost per ounce of a granola cereal. A 15-ounce box of raisin cereal costs $3.90. Which cereal costs more per ounce? Okay, so in this case, we're not looking for the best rate. We're looking for which one is the most expensive. So in other words, we can use the rate given to us for the raisin cereal, 15-ounce box is $3.90, to find out that it costs 26 cents per ounce. Remember, you do that by dividing $3.90 by 15 ounces to find out the cost per ounce. So we did $3.90 divided by 15, and that's what gave us the 26 cents per ounce. Okay. If you go over to the graph, you can find the prices of the granola cereal. Remember that you're looking for how much it costs per 1 ounce. So you need to identify some points on the graph in order to find out that unit rate for the granola cereal. In this case, the cost is hard to determine just by looking at the points, so we have to rely on those ordered pairs that they've given us here. So we know that the cost is $2.50 for 10 ounces. and that means that equates to 25 cents for 1 ounce. And we can also verify that by looking at the $5 for 20 ounces, and that also equates to a price of 25 cents for 1 ounce. Also recall that they use the constant of proportionality here by finding the differences between the Y numbers. So $5 take away $2.50 is the $2.50 you see up here, and then the 20 take away 10 leaves you with 10 ounces, and $2.50 divided by that 10 ounces is still 25 cents per ounce. So what that tells us is that the granola cereal only costs 25 cents per ounce, which means the raisin cereal is the more expensive option. Now I would like for you to try the try it problem. Again, you're given some information within the word problem itself, and then you have to look at the graph to determine the unit rate there, and then make your comparison. All right, come back and check your answer when you're ready. In this problem, calculating the unit rate for the train in the United States is fairly easy. 600 kilometers divided by 2.5 hours is approximately 240 kilometers per hour. So that's pretty straightforward here. Okay. The problem becomes when you try and read the points off the graph. You'll notice that the first 2 points, namely the one at the unit rate ordered pair with the 1, is not directly falling on the grid line for the Y value. We can make a guess as to about where it is, somewhere between 200 and 400, but we don't know exactly. Same thing with the second point at the point 2, comma something. And again, we know it's greater than 600 and smaller than 800, but we don't have a good location for that. It's when you get to the third point, you'll notice that it falls either directly on or very close to the line for on the y-axis for 1,000. So we can use the ordered pair 3, 1,000 to get the best estimate for the speed of the train in Japan, which is approximately 33 1/3 kilometers per hour. So what this tells us is that the train in Japan has the greater speed. Now let's take a closer look at the key concept and some practice problems. Remember that in order to compare proportional relationships represented in different ways, you can find the unit rate or constant of proportionality for each representation. When using a table, find that constant of proportionality, which is the K value, by taking your Y number divided by your X number. Okay, you want to find out how much for 1. On a graph, you're looking for the ordered pair 1, R, if it's easy to identify, or you are finding the difference between your Y values and your X values, and again, you're dividing them. So it's a Y over X relationship. And in the equation, recall that your equation for a proportional relationship is Y equals K times X, where K is the unit rate. Next, I'd like for you to try to solve questions 4 and 5. Come back and check your answer and listen to the explanation in case you make a mistake. Then we'll go on and try some additional problems together. In question 4, Amanda's unit rate is $6 per hour. According to the table, Petra's earnings are $5 per hour, so Amanda earns more per hour. Next, let's take a look at question 5. In the problem, it directly tells us that $3 per pound for dog food at Pat's Pet Palace is that unit rate. But as we look at the graph, you notice that I enlarged this so that you could look closely and see that the line that represents the relationship between the cost and the weight per pound at Mark's Mutt Market does not exactly line up with any of those crosshairs on the graph. So that provides for us just a little bit more of a challenge. However, it's still doable by making some educated, I don't want to call them guesses, but estimates as to where those numbers probably lie. So let's look at the weight here on the graph. At 1 pound, we see that it's not quite $5. At 2 pounds, we're talking about a point that's about halfway, maybe a little bit more than halfway between the 5 and the 10. At 3 pounds, we're looking at a cost that is probably just under halfway between the 10 and the 15. And at 4 pounds, we're talking about a cost that is over $15. Okay, so we can use some educated estimation here to determine that Mark's Mutt Market is going to be charging more per pound than Pat's Pet Palace. How do I know that? Well, look here at this point. We know that halfway between 0 and 5 is the 2.5. And this point is likely closer to the 5 than it is to the 3, which is just over the halfway point. Same thing happens here at the 2 pound mark. Remember that halfway between $5 and $10 would be $7.50. So over $7.50 has got to be the cost of a 2 pound bag of dog food at Mark's Mutt Market. Okay, so I would say that's probably closer to about the $8 mark. Then you go to the 3 pound mark and you're just under halfway between 10 and 15. So you're around $12, maybe $12.50. And at 4 pounds, you're over $15, probably closer to $16. So what I can gather from this is that it looks like at Mark's Mutt Market that we're looking at approximately $4 per pound of dog food. And that would make the lower price at Pat's. Continue working on the practice and problem solving questions. Come back to each one and check your answer before you go on to the next one. That will help you decide if you understand how to solve the problems and where you might need some extra support from me. Come see me if you have questions. And as always, if you need anything at all during your working time, please ask for help. All right, time to check your work on number 6. Pause the video while you do that. And then if you're ready, move on to number 7. Okay, go ahead and check your answer to number 7. If you have any questions, come see me. And now go ahead and check your work and answer for number 8. Again, please see me if you have questions before going on to the next set of problems. We only have 3 additional problems in this practice and problem solving set. So go ahead and try numbers 9, 10, and then 11. And again, come back and check your answers as you finish each one so that you can see and verify that you're doing them correctly. See me if you have questions. Go ahead and check your answers to question number 9 and see me if you have any problems or issues. Then go on to number 10. And here's your answer for number 10. Again, check your work. Make sure that you agree with the unit rates for each plant and the comparison, as well as the error that Winston likely made in his analysis. And when you're ready, move on to question 11. And last but definitely not least, check your work and answers for question 11. Before you move on to your assignment, please check with me if you have any questions, problems, or concerns about any of the work or problems that you've seen here in Lesson 7.5.